We are Japan Engine Corporation, and thank you for watching our presentation about optimal maintenance management of UE engine. Before we start, we would like to introduce about Japan Engine Corporation, so-called J-ENG. In April 2017, Kobe Diesel and the Marine Engine Business Division of Mitsubishi Heavy Industries Marine Machinery were consolidated as Japan Engine Corporation. J-ENG is the only global licensor consistently from development, design, production, sales, and after-sales service, and aiming for contributing to the growth of UE engine and worldwide maritime industries. This slide shows our themes of our technical strategy, which we are actively engaged in research and development. Themes can be broadly divided into two categories: environmental friendliness and digitalization. In terms of environmental friendliness, the themes are further divided into four subcategories, such as reduction targets of NOx, SOx, GHG, and CO2. We are working on engine development and solution development while making various environmental technologies compatible. In this seminar's topic, digitalization, we are implementing efforts to increase the added value of our customers by strengthening our existing services, by utilizing various digital technologies, and by providing support for using new environmentally friendly technologies. Here is our agenda. First, we would like to talk about basic maintenance management of today. First of all, we would like to introduce our current after-sales service scheme. This slide is the main service menu related to spare parts supply management. On the left is a proposal for each time purchasing of spare parts according to customers' inquiries or according to maintenance manuals. In the middle is a proposal for annual bulk purchasing, which we propose bulk purchasing for spares required for the yearly maintenance. At the end, it is a menu that we propose spare parts required for docking of the ship. We currently provide using these menus for spare parts supply management. We are actively engaged in service activities according to the condition of the ships and for the convenience of our customers. In next slide, we would like to introduce each menu a little more specifically. The picture on above shows the normal flow of after-sales service. The flow illustrates the transactions between shipping companies and J-ENG. Normally, the information of the ships will be provided by the ship management companies. We arrange the requested spare parts and job scopes based on their information. Firstly, we will explain about proposal for each time purchasing. Replenishment of consumable parts is the main part of spare parts management based on customer inquiries and maintenance for ordinary running. As a general spare parts purchase, we recommend maintenance based on time-based maintenance intervals as designated in our maintenance manual. Next, we will explain about proposal for annual bulk purchasing. We propose the spare parts that will be necessary for the next year according to the age of the ships and the fleet management status of customers. As a feature, it is positioned as a service that reduces the cost and time burden on customers, and also this menu can support planning customers' spare parts management. Lastly, we will explain about proposal for recommended parts for docking. In this menu, we recommend necessary parts for docking work, considering the docking time and service status in order to provide an optimized docking maintenance work. This menu also has a feature to reduce cost and time burden. This is a service that provides total support for dock parts management and maintenance work planning. Next, we would like to introduce the main service menus related to technical support. First is a menu to carry out on-site inspections and measurements of the main engine by dispatching engineers to vessels. The other is a menu to analyze the performance data of the ship, submit diagnostic report, and give advice on performance improvement. All menus are provided by engine experts who can flexibly respond to the situation of the ship and customer inquiries. In next slide, we would like to introduce the contents of onboard services and performance evaluation. Here are examples of the onboard service. In onboard services, we dispatch engineers to the ship to undertake engine inspection, measurement, and work supervising to vessels in service or docking. In addition, according to the inspection result, we can check the condition of parts of main engine. We can judge the quality, and we can propose a maintenance plan. The photo on the left shows the piston overhaul, and on the right shows main bearing overhaul. In these sort of opportunities, we also provide technical guidance to ship crews. Here are examples of performance evaluation service. In performance evaluation service, we provide analysis report on engine performance data by analyzing engine operation data measured by the ship side during ship service. The data and reports are collected by email, and basically, we advise appropriately on performance and conditions accordingly to the customer's requests. Depending on the diagnosis result, mainly, we provide proposals for performance recovery, and we advise to prevent troubles by providing technical support. In this scheme, our after-sales service provides support to our customers through 3 menus of spare parts management and 2 menus of technical support. Next, we will talk about subscription menu of maintenance and inspection. Our subscription menu of maintenance and inspection is a flat rate service that packages with onboard service and technical support services. The package menu includes maintenance planning, onboard inspections, and performance evaluation. This service can seamlessly provide spare parts maintenance management and technical support. In this topic, we will give you an overview of this service and the effects we have experienced. Subscription menu of maintenance and inspection was born from customers' feedback. There were many requests, such as how to balance safe operation and proper maintenance, how to carry out planned maintenance with a limited budget, how to manage the shortage of ship crews, and how to manage technology transfer. We have decided to propose this subscription menu for such customers managing ships calling at Japan regularly. After formulating and agreeing on a maintenance plan with the customer, we carry out parts management and technical support for the ships according to the maintenance plan. It is an effective menu to reduce the burden that customers cannot see and to eliminate anxiety. This slide is an example of a subscription menu of maintenance and inspection. In this service, we have slightly changed the conventional flow of transactions and made information transmission seamless so that the ships and J-ENG can communicate directly. As a result, we can provide support to the vessel more timely and accurately with less help from the vessel management company. In addition, by regularly sharing the information of the vessel condition with us, we are able to give more accurate proposals to the vessel management company, which led to an improvement in service quality. Furthermore, various information are always shared between the ship management company, and J-ENG in order to respond smoothly. This is a sample of yearly plan subscription menu of maintenance and inspection. In this case, we carry out maintenance on parts such as fuel bulbs, exhaust bulbs, cylinder liners, piston rings, and crankcase. And they are regularly inspected by our engineers. In addition, if there is a docking, the inspection menu related to the docking job scope can be added in the maintenance plan. We share operation data and submit reports on a regular basis with performance analysis. Through this service, we have experienced two things. One is that planned maintenance and proper maintenance are important factors for long-term use of engine parts. The other is that regular performance analysis is important for extending the usage time of engine parts. When we actually carried out regular maintenance and continued to observe the condition of parts, in some cases, we found engine parts in good condition even after the usage time limit was exceeded. Through these experiences, we believe that the subscription menu of maintenance and inspection has two good effects. First is the economic effect. By better understanding the condition of engine parts, it is possible to determine the appropriate replacement time of parts, and we can support the proper asset management and maintenance for our customers. Second is the effect on improving service quality. By sharing operation data and maintenance information, we believe that by reducing unproductive work and noticing defects and improvements, we can contribute to the prevention of failures and retainment of performance. In the next topic, we would like to show our pathway to optimal maintenance management. We are continuously making our efforts to deepen and create the value of our services in order to realize optimal after-sales service. The existing after-sales service has been able to increase the value of the service through subscription menu of maintenance and inspection in response to our customers' feedback. As a next step, we are currently aiming for comprehensive services, and we believe that this can be achieved by sharing and utilizing data. In addition, we would like to increase the value of the services we provide to our customers by utilizing advanced support utilizing data AI. In next slide, we will introduce the status of efforts toward the realization of comprehensive services. In order to consider comprehensive service, we consider the issues which we found in the previous subscription menu of maintenance and inspection. We found two issues to challenge regarding economic benefits. One is to deal with necessary parts selection without spot checking. The other is to deal with targeting irregularly scheduled cargo vessels. Originally, the subscription menu of maintenance and inspection includes dispatching engineers regularly to the ship, which made it possible to grasp the status of conditions. Regular port calls to Japan with regular routes makes this service feasible. In order to apply this service to all vessels, we need to clear this issue. There are two similar issues regarding the effects of improving service quality. One is sustainable data sharing, and the other is the establishment of parts conditions evaluation method instead of visual checks. In many cases in subscription menu of maintenance and inspection, we needed to make decisions by communicating information through people and checking the status of actual parts by visual checking. This issue is necessary to be clear as well. Based on these experiences, we focused on the value of data and decided to take an approach to solve this problem by sharing and utilizing data. Specifically, we are aiming to visualize the operating status of the engine and the status of engine parts by sharing and utilizing data. We believe we can establish a method to analyze the status of the main engine and a method to visualize the expected next maintenance time based on the measured and shared data. This is a prototype of a comprehensive service architecture designed for data sharing and utilizing. In addition to the architecture of our ongoing subscription menu explained previously, data distribution is centered on the data sharing infrastructure. For example, IoS Open Platform of ShipDC is expected to form such a service infrastructure with fairness and safety. We believe that our service menu can utilize this data sharing infrastructure to carry out performance diagnosis, maintenance planning, and to solve the mentioned issues. In addition, we believe that such a data sharing platform will be effectively utilized for the entire stakeholders, and shipping companies will be able to receive products and services not only from our company, but also from various companies. In order to realize this service architecture, we are promoting efforts to update our existing services by utilizing data. In this slide, we would like to introduce the online tools for the performance diagnosis service. The ShipDC portal, which is an IoS-OP web service, is equipped with a function to visualize the performance of the main engine. By importing data into IoS-OP, parameters related to engine performance can be viewed as shown on this slide. Our performance diagnosis can also be collected by requesting through this portal. This is a third-party online tool, which is tied up with the UE engine. Ticoma Expert on the left is a web service similar to ShipDC's portal site. You can browse performance parameters by entering the data of engine operation. The feature of this product is that the performance diagnosis is automatically performed and the result can be obtained immediately. On the right is the Lifecycle Administrator, which is an edge computing system with a diagnostic function installed on the ship. In addition to performance analysis, when troubleshooting, necessary manuals can be viewed in conjunction with each other, and the condition monitoring function calculates the optimum fuel injection timing and lubrication rate. Here are the examples of a condition monitoring system which can be applied to UE engine. These are condition monitoring systems for bearings. There are three main sensors for engine bearings: temperature sensor for crosseye bearing, crank fin bearing, and main bearing. Bearing wear sensor on the right side is a system that monitors the position of moving parts and shows how much wear is progressing due to the displacement of the position. It is also possible to install a moisture sensor for lubricating oil to detect bearing wear. Next is an example of a monitoring system around the combustion chamber. On the left side, you can see the cylinder pressure monitoring system that monitors the combustion pressure, and on the right side, you can see the temperature monitoring device of the cylinder liner, and both items are available for UE engines. Here is an example of engine control system. The engine control system has a standard equipped system such as engine control unit called ECU, input-output unit called MIO, and analog sampling unit called ASU. The data acquired by these units is collected on a personal computer via a communication hub. By linking with the onboard server of the ship, you are all set to send the data to land. Such engine control data can also be utilized to support optimal performance operation and maintenance of electronically controlled parts. From here, we would like to talk about some examples of condition diagnosis based on the data. First example is about data utilization for turbocharger performance recovery. In the graph, the horizontal axis is a load and the vertical axis is the rotation speed of the turbocharger. Blue is the data of before the cleaning, and red is the data of after the cleaning. By using such continuous multipoint data, it becomes easier to grasp the status, which allows us to identify the deterioration of performance and planning the maintenance. Depending on how the data is utilized, we believe that it will lead to proposals of reducing fuel consumption, optimal maintenance intervals, and early detection of failure. Next are some examples of condition monitoring of electronic control devices. The graph on the upper left shows the operating status of the fuel injection pump. The lower left shows the operating status of the high-pressure pump. And the right side shows the operating status of the exhaust valve. These are the data of normal condition, and you can see that there are no abnormalities. In this way, we can visualize the data in the engine control system, and this makes it possible to monitor the status of various devices. If there are no abnormalities, you can make a decision to extend the maintenance timing, which leads to optimization of the maintenance period. We believe that data is also important for improving service quality. The slide icons are the main categories of after-sales services we provide, but the quality of each service can be improved by sharing appropriate information. By constantly sharing the operation data and maintenance information of the ship with our customers, we believe that we will be able to provide services that meet the needs of our customers, even in conventional parts proposals and onboard maintenance. Comprehensive maintenance service is a performance diagnosis and maintenance planning based on data. Furthermore, it is a service that can provide comprehensive added values to customers by improving service qualities due to the cross-functional effects of each service. As you can see from the explanation so far, we can tell that sharing and utilizing of data is inevitable to realize the optimal maintenance. We also believe that shared data infrastructure can be also applicable to further advanced support solution as condition-based maintenance and digital twin. Next topic is about future outlook regarding the optimal maintenance management. We are also engaged in research and development of advanced support technology in order to provide optimal after-sales service for our customers. Areas that we are particularly focusing on are condition-based maintenance and digital twin. In this part, we will briefly introduce each purpose and concept. First, we would like to introduce the purpose of condition-based maintenance. Here, the image of CBM is represented by this graph. The horizontal axis is the operating time, and the vertical axis is the curve of the deterioration life of the parts. The line written in green is the maintenance period of TBM, which means the maintenance is performed on a time basis. If the TBM reaches the end of its life as shown by the red line before the limit of operation time comes, there will be a failure. In our CBM efforts, we use data to prevent such early failures. If the parts are still fully usable, we are aiming to establish methods which enables to extend the maintenance period and reduce operating costs. CBM and equipment condition diagnosis methods are being actively challenged not only by our company but also by various shipping companies and marine manufacturers. For example, Class NK published the CBM guidelines in July 2019. We are also working on joint development of CBM with NYK, MTI, and Class NK. We will continuously carry out data analysis of engine condition and element tests using actual vessels to establish and maintain condition evaluation methods. The other is to focus on the development of advanced technologies such as digital twin, which utilizes simulation technologies. On the ship shown on the slide, there's an idea to expand the performance diagnosis function of the electronically controlled system of the main engine in order to strengthen the support for ship crews. And on land, we have another concept of microservices that enable customers and stakeholders to effectively utilize the data collected from the ship. In addition to providing services, we also would like to create values through various collaborations. With such an architecture, we would like to continuously increase the value of energy-saving operation, safe operation, and optimal maintenance planning. IoS-OP promotes data distribution and utilization so that the industry can respond to changes in the environment and also to achieve sustainable growth. This slide is an example of a simple architecture for data sharing infrastructure. Based on the common rules regarding data usage, IOSOP has a mechanism that makes it easy to sell the rights of entrusted data, to share data, and to use solutions provided by third parties. Utilizing iOS Open Platform increases the added values, which leads to promote the circulation of data utilization, which enhances the digital contents. At last, here are the summaries of our lecture for you to note. In this lecture, we introduced 4 parts of our efforts of optimal maintenance services based on our after-sales service experiences. We mainly explained that the utilization of data is effective for realizing better after-sales service. We also explained that data sharing and utilization services can be enhanced by advanced assistive technologies such as CBM and digital twin. And IOSOP is an effective data sharing platform in such data sharing and utilization efforts. In this way, digitalization efforts are becoming more active in the maritime industry as well. Japan Engine Corporation will continue to make various efforts to provide valuable products and services to customers by utilizing our development knowledge, which we have cultivated until today. Thank you for your valuable time and your attention.